Wanted to welcome everybody, and I hope you're enjoying the conference. We appreciate you stopping by the Rockwool Stonewall Insulation Sustainable Solutions presentation here. And with that, I'm going to introduce, we have a lot of people entering the waiting room. I'm going to introduce my colleague, Alejandra Nieto. She is our Sustainability Manager with Rockwool. And my name is Pamela Sadler, and I actually am the Specification Manager for California and Nevada. So we want to get into our approach to sustainability and how Stonewall works into this bigger picture. Our sustainability approach is basically twofold. Rockwool's operations and products have many positive value creation, let's say a handprint, if you will, on many of the social, economic, and environmental aspects of sustainability. At the same time, the production of our products is associated with a negative impact. We know that's not enough just to talk about it. We need to know more than just the products and their benefits. So to quantify our impact, set goals for reaching our footprint, and to measure and communicate our progress, we've been using the United Nations Sustainable Development Goals framework since 2016. In short, the handprint is a positive environmental impact of what you produce, while footprint is a negative impact of how you produce it. In North America, our areas of focus for sustainability go hand in hand with our Sustainable Development Goals and our SBTi commitments. Not only is Rockwool the only insulation on the CAL FIRE approved builders material list, but more importantly, it's the only insulation with WUI certification. So I bring that into the picture because obviously with each fire that we've been experiencing, carbon is released into the atmosphere, toxic smoke and ash are deposited in surrounding neighborhoods, and every footstep and every door opening stirs them into the air again. So California proposed legislature requires that building materials be non-combustible and fire resilient. This creates a more efficient and sustainable air quality for us. Getting to the carbon neutral goal, we need to obviously improve the energy efficiency of our buildings, and this applies to both new and especially our existing inventory of buildings. Applying passive strategies as a primary measure, followed by renewable energy and efficient grid interaction, using low carbon materials to reduce our embodied carbon, and choosing the solutions that are environmentally conscientious while providing the necessary performance attributes. So we need to incorporate passive strategies to reduce operational loads and active strategies to reduce and come up with high energy systems efficiency, renewable energy sources, and appropriate grid interaction. As we know, there's two types of building carbon emissions. We have our embodied carbon and operational carbon. Embodied carbon refers to the CO2 emitted during the life cycle of the building materials, including extraction, manufacture, transport, installation, and use and end of life. Our operational carbon is the CO2 emitted from the energy used in the building during its lifetime, which of course includes the energy required to heat, cool, and light a building, as well as to heat water and power appliances. As we can see by the graph, we know that high performance buildings can significantly reduce the operational carbon emissions. However, with that, there is an increased focus on the embodied carbon of the materials being used. When considering the overall impact of each material for a project, it's not always about how high the embodied emissions are of that particular product, but also how much of that product is used in the building. For the most part, structural elements will have the highest impact on embodied carbon based on their individual impact and a high volume of that product used. However, next on the scale are facade products, including insulation. One thing to keep in mind is that the insulation is the primary material that helps reduce the overall energy and operational emissions of a building as a final product. So when we think about insulation and Stonewall specifically, in its lifetime, the amount of carbon emissions saved by using insulation significantly outperforms the upfront emissions from its production. Rockwool products are application specific. Our exterior continuous insulation and our roofing boards come in a variety of densities, depending upon your application. Rockwool bats are semi-rigid, friction fit for optimum acoustics, thermal efficiency, and fire safety. And if you note, the lower right-hand corner shows a Cavity Rock Black product, which has an integral black scrim which is not only cost and time effective, but it's a great solution for all of your open jointed rain screen assemblies, still bringing the non-combustibility and non-smoke and all of our sustainable issues to the front. Companies such as Google have been one of the most stringent building materials, or have one of the most stringent building materials list. They focus on sustainability, fire safety, efficiency, and ultimately net zero. Stone wool has a long history of being the insulation of choice for many sustainably minded companies such as Google and Amazon. Okay, I'm going to turn this over to my colleague, Alejandra.
Thank you. So what makes a building product truly sustainable? What does a sustainable material really mean? And so when we think about sustainability of materials, it has to encompass the many aspects and attributes that create an impact to both the environment, but also to the building occupants of the final building. It's not just a single comparison, but it has to be a holistic overview of the overall benefits and impacts of a specific product. So what I'm highlighting here is a few of the buckets you could call that encompass sustainable materials. So we've got environmental impacts, which includes not only the carbon emissions or the GWP value of a particular product, but also what is their contribution to contamination to air and water? What is their contribution to resource depletion and how the raw materials are being sourced, among others. When it comes to material composition, it's really important for manufacturers to be very transparent in terms of what are the ingredients that are going into their products. We see a rise in manufacturers coming out with health product declarations, also known as HPDs, or declare labels to highlight the health aspects of their materials. And so what we need to consider when it comes to the composition of this is really understanding, again, what are the ingredients? What kind of ingredients are they using? Are they using flame retardants? What kind of blowing agents? How does that harm, the environment? What is going into any binders that are being used in the production of the manufacturing of particular products? What do the VOC emissions that are being emitted from the product look like, and making sure that we have solutions that are compliant with the required regulations. When it comes to occupant comfort, building materials, and in this case, insulation, can have a significant impact on the final comfort for building occupants. So again, kind of highlighting, potential emissions from all of the products inside a home or inside a building. And this also includes stuff like emissions from the furniture that we're selecting, emissions from the finishes that we're selecting. These are, of course, going to be the primary materials, but also it does get to the products that are being used in our wall assemblies. But then when we think about occupant comfort and occupant health, we also have to consider thermal comfort and acoustical comfort for the building occupant at the end of the day. So all of these factors are going to play a critical point when we're selecting materials. And then now what we're seeing is circularity being increasingly important and part of the conversation to ensure that buildings at their end of life have options for ease of deconstruction or ease of disassembly of these materials to promote the reuse and the recycling of these materials as applicable. So choosing products that enable this and are going to make it easier at this stage of life is also something that we need to consider, and encompassing all for a sustainable material. So we're all familiar with environmental product declarations, EPDs, and what we're seeing is an increase in product comparisons in charts similar to what I have on the slide, essentially comparing product to product. What is their environmental impact? What is their global warming potential? And so this is what I have here on the slide sharing to you. However, what's really important to know is that EPDs comparisons between different products, it's not an exact science. So although there are industry standard standardized documentations that we have to follow when developing our EPDs. There can be differences that are going to create differences in the results and the quality of these results. So this includes, of course, what type of LCA software is being used? What data sets is that LCA software pulling numbers from? If it's not product specific, sometimes we use general databases. Some of the assumptions that can be made depending on who the life cycle practitioner is. Similar to energy modeling, the practitioner controls a lot of the variables, and not to say that there's inaccuracies in any of these EPDs. For the most part, you should be relying on EPDs that are third-party verified for that specific reason, to make sure that there is accuracy. But it makes it challenging when there's these differences to make accurate comparisons. However, charts like what we have on the screen, we see them all the time. That's the reality. I'll get into some of the tools that are out there that's enabling this, but it is a good starting way to start looking at comparisons to make informed decisions as to what products are being used in your building, right? But GWP is not the only thing that's important. Sorry, Pam, can you go back to the previous slide? GWP is not the only thing that's important. And you have to also consider what part of the process or what part of the life cycle is contributing towards the global warming potential of these products. And so that can mean different things for different types of products. So it can be the manufacturing process that has the highest contributions. It could be the type of blowing agents that they're using that have the highest contributions, some of the flame retardants. And of course, we also have to think about the emissions beyond A1 to A3. So is there any in-situ off-gassing from products that is happening that's not captured in that initial stage and won't be seen in a comparison such as what I have on the screen right now? If we deep dive a little bit further into mineral wool specifically, it's really important to know that product-specific EPDs are the way to go. And it's something that you should be asking for from all your manufacturers, as opposed to relying on industry averages. They're going to provide a much greater transparency and much accuracy in the results. As you can see here, I'm showcasing different EPDs from different mineral wool manufacturers. And you can see, in fact, that there is differences in the performance, right? And so you've got manufacturer A, for example, versus manufacturer B that are both product-specific EPDs. And then you've got the industry average. And as you can see, the performance is going to vary. So we have to be cognizant when we're seeing charts that are comparing numbers, what is the number that they're using? And is that number applicable to the product that you're actually selecting, right? So for example, if you were going to use Rockwool stone wool specifically, looking at our product specific EPD is going to be critical in your calculations, in your comparisons, and you shouldn't be relying on the industry average to make your decisions. In addition to that, it's also important to ensure that when you're making these comparisons, that you're comparing like product to like product. So for example, when it comes to certain insulations, any kind of mineral wool insulation, generally speaking, a higher density product is going to have a higher environmental impact. So we want to make sure that we're not comparing the value of a high density product if you're looking for a product to be used in between wood studs, for example, that would be a light density bat. Their performance and their impact is going to be different because these products are designed for different applications. As a company, we support industry initiatives around the topic of sustainability and, of course, embodied carbon. We see tools such as EC3, which is an embodied carbon in construction assessment tool, a key to enabling the design of lower carbon buildings. With that, tools that link to this database, such as the new release Passive House Ribbon, these are instrumental to making the assessments easier for designers and make a more streamlined process for project teams. And so I'm just showcasing a snapshot, if you haven't been on EC3 yet, what it looks like to search products into their database, what information is provided. It gives you the GWP for that product that you can easily, in the procurement phase, compare like products to like products. And now with the Passive House ribbon, for those of you using the PHPP tool, this is now all embedded within that, which makes this whole process much easier. And of course, going back to what makes a product truly sustainable, we really have to consider everything beyond the global warming potential to look at the full encompassing sustainability benefit. When it comes to product transparency, making sure that your manufacturers are using standardized documentations that are compliant with regulations, such as environmental product declarations, health product declarations, and declare labels. And when it comes to stone wool specifically, there is varying benefits to this type of insulation. We've got high durability and performance when it's installed in the correct application, both on interior side and also on the exterior. Long-term thermal performance with no lack of thermal degradation throughout the years, high dimensional stability, very moisture resistant, and designed for circularity.
Okay, we seem to have lost Alejandra and her sound for a minute. So as you can see from the rest of the slide, dimensional stability, the product stone wool is actually hydrophobic, which does not allow for any growth in the product or inside of your assembly due to the stone wool itself. Low carbon and chemical footprint and designed for circularity. This is a chart that goes over our Rockwell sustainability certification. It's a full list of our products and their relevant sustainability certifications. So while the Rockwell site does contain, we also have a one-pager that has all of our sustainability links, and you can just click on those and get to your EPDs and your HPDs. Our WUI certification, where stone wool is the only mineral wool on the CAL FIRE approved builders material list. And again, it's not California specific. Fire is fire. It's not WUI specific. It's urban. It's WUI. It's the interface. Fire in general. So we actually have WUI certification on our exterior board products, and we are on the approved builders material list. So if you have an interest in that, then you can reach out. So at this point, if you have any questions, that would be great. Here is our contact information again for you to take down. Please feel free to reach out if you have any projects. I just want to give a shout out to our Rockwool Building Science Department. This is a completely complimentary service, and they do moisture analysis, dew point, WUFI. They also do thermal modeling, acoustical modeling. So please, feel free to reach out if you have a project where you're wondering how to obtain a specific code and if your assembly is the optimum assembly. And we can run it by our building science department, and they can turn that around within 24 hours to you. We'd love to hear about your projects.